The last video that we're going to do deals with rational functions and determining the domain of a rational function and also what happens if we multiply and divide rational functions. So let's take a look. This first one is just to determine the domain of r of x. Now, we did this already with just a rational expression saying what values will make the denominator 0. And that's exactly what we're going to do here. We want to figure out what values will make the denominator 0. And whatever ones make the denominator 0, we know that's a problem and you can't do it. So therefore, since we can't do that, that's what's going to put a restriction on the domain. So the first thing we're going to figure out is what values will make the denominator 0. Whatever they are, that's going to put a restriction on the domain. And then let's figure out what the actual domain is. So what we have here is just we're only going to take a look at the denominator because that's all we're being asked to do. So first off, factor out the 4. X squared minus 4x minus 5, because we just divide every single one of those by 4. And then let's go through and factor it completely. Excuse me. So first terms in each are x. Factors of 5 that differ by 4. So we definitely have those because that's 5 and that is 1. This tells me the signs are different. So plus, minus. And then factors of 5 that differ by 4, well, that's 5 and 1. 5 is going to go with the negative sign because, again, here's my negative. That tells me which one is larger. 1 goes here. So this means x cannot equal negative 1, positive 5. Depending upon how you're asked to go through and write the domain, you can say, all right, well, the domain is the set of all x such that x is an element of the real numbers, and then except x cannot equal negative 1, 5. So if you're allowed to use set builder notation, that would be one way. Now, we're going to use also interval notation. So for interval notation, remember you start with the lowest value. Lowest value is going to be negative infinity, and I cannot be negative infinity. So that's why we have the parenthesis here instead of the bracket. So negative infinity to my lowest value, which is negative 1. I can't be that value because if I am, then the denominator is 0. And then we're going to union that with going from negative 1 to 5, and again, we can't be either one of those, and then union that with finally the last segment, which is from 5 to infinity. So that's the domain, and there's 2 different ways in which to write it. And we're only going to take a look at the denominator to figure out what the domain is. If you were just to write x cannot be negative 1 and 5, that is not telling me what the domain is. That's telling me what the restrictions are. So if the question says, what are the restrictions to the domain, you would say, okay, well, x cannot equal negative 1, 5. But if you're asked to determine the domain, you would have to give me one of these 2. All right, next one. So here we're going to go through and, again, you can either multiply or divide. So in this case, I'm asked to go ahead and just multiply 2 functions. If it wanted me to divide, then I would have a division symbol in here. We've already done videos on how to multiply and how to divide. So in this case, we're just trying to showcase what you do when you're trying to figure out, the functions if it's an operation of 2 functions. So here I've got 2 functions, f of x and g of x. And in this case, I'm asked to go ahead and multiply them. So to find capital R of x, I'm going to take f of x, which is 3x minus 21 divided by x squared minus 9x plus 14. And I'm going to multiply by 2x squared minus 8, 3x plus 6. And again, if it had division, then I would show division of this and then use the same process that we've learned in the previous videos. So now going ahead from here, I'm going to factor everything. So if I factor this, I get a factor of 3 out. I get x minus 7. That's a 7. Divided by, and this is a quadratic, so I need 2 sets. First terms in each are x and x. Factors of 14 that add to give me 9. Well, there are factors of 14 that add to give me 9. This says the signs are the same. This says that they're both negative. And factors of 14 to add to give me 9, well, that would be 2 and 7. So we'll put 2 here, 7 here. Multiply that by, all right, so first thing I got to do is take out the common factor. The common factor, I'm going to use another color here just so that it's not as confusing, but this will turn into 2 times x squared minus 4. All right, now I'm going to go through and break that down further for this second fraction. And I have 2 times. And then I go ahead and factor this. This is the difference of 2 squares, so I get x plus 2, x minus 2. My denominator then, if I look at this, I've got to factor a 3 out. And then when I divide each of those by 3, I get x plus 2. All right, so time to start lopping off parts here and start getting rid of things that are common factors. So I see here I've got a 3 here and I've got a 3 down here. So bye, have a nice day. I've got an x minus 7 here and an x minus 7 here. So toodles, have a nice one. X minus 2, x minus 2. So this whole first fraction has been simplified so there's nothing left already. Then I look over here and I've got an x plus 2 and an x plus 2. All right, so this came out way too nice, which happens. Sometimes they come out not too nice, sometimes they come out nice. So that means, wait a minute, the answer to this is 2. So that means no matter what value x is, this will always come out to be 2. No matter what. So if I let x be 5, it's going to come out to be 2. If I let x be negative 5,273, it's going to come out to be 2. So this is what will always be in this particular case. It just happens to be that's the way this one came out. All right, so again, thank you so much for watching and paying attention and hopefully learning from the stuff that we're working on here at Charahoe High School. If you like what you saw, and there's plenty of other videos that may be of assistance, feel free to subscribe to our Charahoe Pre-Calculus YouTube channel. Thank you, and have a great rest of your day.